In this lecture, we look at calculating infinity as a limit. We not only want to consider limits as x goes to infinity, but we also consider limits in which the output value, y, of the function goes to infinity. Limits in which infinity is our answer, is itself the limit. The expression the limit as x goes to a from above of f of x equals infinity means that f of x, the output, is growing without bound as x gets closer and closer to the real number a from the right, from larger values. Let's look at this graph as an example. We've graphed here in blue a particular function, and then drawn in red is a vertical asymptote, x equals minus 1, and in green is drawn a horizontal asymptote, y equals 2. The limit as x approaches minus 1 from the left, let's look at x values creeping up on minus 1, approaching that red asymptote. As the x values approach minus 1, the blue curve shoots up to infinity. So the limit as x approaches minus 1 from the left is positive infinity. On the other hand, as we approach this vertical asymptote in red, if we approach x equals minus 1 from the right, imagine x values creeping along the x-axis, coming close to that red asymptote from the right, we ask, what is the blue curve doing? What are the y values? They're shooting down to negative infinity. The y values plummet, dropping below any given negative number. So as x gets closer to minus 1 from the right, then the limit is minus infinity. Now, in this picture, we've drawn a green asymptote, a horizontal asymptote. The horizontal asymptote is going to represent x going off to infinity. X is shooting off to the right side of our picture or the left side, and the function in blue is creeping up close to that green line. So the limit as x goes to positive infinity of f of x is the finite number 2, where the green asymptote is, and the limit as x goes to minus infinity as x shoots to the left is also 2. And by the way, in this picture there's a hole at 1.5, and this just tells us that the function in blue is undefined there, even though the limit as x goes to 3 of the function is 1.5. Limits as x goes to infinity or negative infinity are indicative of horizontal asymptotes. For example, here the green line is a horizontal asymptote. From the graph, we might look at the asymptotes in red and green. The vertical asymptote in red is x equals minus 3. The horizontal asymptote is y equals 1. As x approaches minus 3 from the right, as my x values creep up on that red line, the blue curve shoots down to negative infinity, but as x approaches minus 3 from the left, then the blue curve shoots up to positive infinity. That red asymptote is telling us that we're going to get answers of minus infinity and infinity. However, the green horizontal asymptote tells us that as x goes to infinity, the output is going to some finite number, in this case 1. As x goes to positive infinity or minus infinity, the limit here is going to be 1. The red vertical asymptote is going to give us an answer of infinity or minus infinity. The green horizontal asymptote is going to be a limit as x goes to infinity. Here's another example. This graph has asymptotes in red at x equals minus 4 and x equals minus 2. So the two vertical asymptotes, and then there's a green asymptote at y equals 10. The asymptotes in red, the one at x equals minus 4, tell me that as x approaches minus 4 from the left, my function in blue shoots down to minus infinity, but if x approaches minus 4 from the right, it shoots up to positive infinity. Same way at minus 2, approaching from the left of that red x equals minus 2 asymptote, my function is shooting up. If I approach minus 2 from the right, my function is shooting down. Meanwhile, there's a green asymptote that tells me that as x goes off to the right or to the left, my y values are approaching 10. In the next presentation, we look at limits that give us the interesting number e.